Hi, welcome to KSR Datavizon Snowflake program. Today, in this video, we are going to discuss about Snowflake Data Cloud. The elements we are going to discuss here is what is Snowflake Data Cloud, Snowflake Key Features, Oracle versus Snowflake. If you see these points over here on a first slide, Snowflake Data Cloud, one of the few enterprise-ready cloud data warehouses. What that means? So that means you no need to have any install or anything. It's a readily available cloud data warehouses like other vendors are also providing. Example like Google, BigQuery, AWS, Redshift, or Azure. Also, we have cloud data warehouses providing. Here, Snowflake is also one of leveraging all these clouds. That means to say, it being installed on top of these clouds. Any one of the cloud you can choose at the time of you creating an account, and then you can have your account installed on a particular cloud account, whichever on your choice. So Snowflake is also one of the few enterprise-ready cloud data warehouse, like I mentioned the other cloud houses. The next point says no hardware or software to select, install, configure, or manage. So whenever we go to the on-premise, so we always need to acquire a hardware. So example 20 TB or 30 TB of requirement you have to acquire the hardware, and you have to work closely with the DBAs to get the hardware to be installed and configure to get the connections to be done to your local consoles, and DBAs will start managing it going forward. But in the Snowflake, there is no hardware or a software needed, and everything will get managed by a Snowflake team. So the next point says no dedicated resources required for setup, management, or support like in-house servers. So on a single word, if you can conclude this point, it's a freedom from DBAs. What that means? So usually in on-premise, when once we have a DB ready, so we will have a DBAs will set up and will managing the DBs going forward, like a performance or including a new racks, or clustering it, or removing the unnecessary data, are moving around the fail-safe information. All this will be taken care by the DBAs on a on-premise. But Snowflake, we don't need a dedicated resources. I mean to say, there is no need of any DBAs or any, especially a team to handle these DBAs. So this all will be taken care by a Snowflake team, including management. If you want to set up something on a new account for a customer, so all you need is just you provide the details on a console, your account will be ready. So we don't need anyone's help over here. An individual can take care of it. So the next point says automatically scales both up and down to get the right balance of performance versus cost. So let's take an example. So we got a requirement, project requirement saying we have to create some KPIs for a marketing team. So we have to deal with the big data. Probably think that there is a 5 TB of data we need to handle. So the on-premise database racks are currently within an 8x or a 4x racks we have. The what happens when you file the queries are to create the decision making KPIs. So you can't scale up it. So what happens is it takes that own time because the computer fixed and the resources are fixed on premise. You can't scale up it. So the decision making information, getting that information takes a time. So, but in a Snowflake, it automatically scales by the setup you have done. You can scale up or down. So up in sense, in case if you want to speeder results or you have some important queries to be executed and we need to provide it to the marketing team, then you can scale up. Scale down. So we want to allow some space to the important queries and we can run the other queries later sometime, which doesn't impact any kind of business. In that case, we can scale down it. So the scale up and scale down, we can able to balance the performance versus cost. So the performance, how quick you need, so that cost you pay. How less importance it is to you, you can reduce the cost based on that. So now we'll discuss about key features of a Snowflake. So these key features, I want to add a point here. So whoever is trying to give an examination or certification of a Snowflake, like a Snow Pro or Introduction to Snowflake, this key features is one of the important topics you need to understand, and there will be a multiple questions from this area. So let's see the first point. That is a query optimization. So query optimization, by name of the meaning itself, we can say something we are trying to optimize here. Okay, so let's read the statement. By using clustering and partitioning, Snowflake may optimize a query on its own. right? So partitioning. So when it comes to your partitioning, we know day partitions, cluster, week partitions, or some kind of location partitions. We would have been created these partitions in a Hadoop or a different databases. You can apply a partition, column based partition. In Oracle also we have a column based partitions or any list partitions. There are multiple partitions like that. In Snowflake itself will create a micro partitions for each and every table. There is no specially you need to apply a partition on the table. So we know the benefits of having the partition. So to retrieve the results quicker, that means example, there is a table called as a location table. Okay, so you've been capturing information from a multiple locations, but when you are querying something on a particular country, that is like I need only India information. So when you put where location is equals to India, it will go to that particular partition only and fetch the information for you. It will be quicker than scanning the whole table. That's what the benefit of this partition. So what is clustering? Clustering is something, but you want to group something. So I want to group all the Asian countries at a one cluster. So whenever there are some KPIs running, there are some graphs are running which needs to pull the data belongs to the Asian countries. So in that case, when they put the clustering key on Asia, so what happens is the results will be quicker when they pull from the table. Okay, as I said, partitioning, micro partitions will be managed by a Snowflake team. If you want on additional on top of it, if you want a clustering, you can add a clustering on it. It simply add a clustering commands will be there. Either you can do it via console or via any other Python scripts you are doing, or using a CLI client called as a SnowSQL in a Snowflake. Okay, so as I said, it's Snowflake will handle it. Next one, it with Snowflake, query optimization isn't something to be concerned about. So we no need to concerned about this one. So in on-premise, whenever in on-premise, when you have 1,000 lines of code, we always see, we will try to create a explain plan for it, and we will try to understand what table or what table scan is actually taking a long time, or if we can apply some other clauses to bring it down into a good performance, right? So all this information, the query optimization here in the Snowflake will be taking care. Okay, so next one, secure data sharing. Yeah, this is one of the important concept and which separates the Snowflake from other cloud data warehouses. So what is shared data sharing here? Data can be exchanged securely from one account to another using a Snowflake database tables, views, or a UDFs, user defined functions. So what it means? So there is a table created called as a location or employee table, let's think. So you want to share this data with someone else, but you don't want to give an access of the whole account to a particular person. So in that scenarios, what you can do is you can just create a share in the Snowflake. Share is a one of the concepts in a Snowflake. You create a share and provide that share to the particular consumer, that whoever is going to take example, a client asks, he wants to see some data, or he wants to run some kind of metrics on top of it. So you can just provide a share to him. So when you create a share, okay, how the data will be stored. So let's take a one example. So example, you have an account, you have created an employee table. Okay, so the location example location called A is there. Okay, you made a share to a consumer. Okay, so when you provide a share to the consumer, the table, it won't create any extra space or it won't cost you anything. So what happens, you are simply creating a on same location information you're trying to share to the consumer. So what this guy will do, this guy will just when he fires the table, it actually undergoes to the same location and provides the information to the consumer. Okay, so usually in a current world, in on-premise world, what happens if you want to share some information via files or something, we use an FTP, right, file transfer protocol. So it's a similar kind of stuff. All kind of security stuff and everything will be taken care by the Snowflake team, so we don't need to worry. Usually in on-premise, what happens if you're trying to do an FTP, you need to have a Unix servers where you have to share both encryption key, decryption keys, and public key and private key, everything. So it is also similar concept, but it happens via a simple share concept what we have in a Snowflake. And you can share the actual location to the particular consumer, so he will utilize until he wants. So once the purpose of this create share is completed, you can delete that share. Okay, so the next one, if you see, support from a file formats. So Snowflake supports all kind of data information, structured, unstructured, semi-structured. So example, you can see here, there is a JSON, Avro, ORC, Parquet, XML, semi-structured, all kind of data it can able to handle. And we need to, and you can see there is a caps of variant column type. So this variant column type is a one of the data type of the column we can call. So what happens is it can able to capture all the unstructured information or a big description information. Everything can be captured in this variant. The next concept is caching. So this caching is also one of the important topic, and you can expect a 3 to 4 questions on this caching while you are attempting any Snow Pro certification or introduction to Snowflake certification. So let's understand the caching concept here. Snowflake has a caching strategy that allows the results of the same query to be quickly returned from the cache when the query is repeated. So what that means? So there is an example, you have a query, as we discussed that there is a location table. So we discussed we need an Asian country information. Okay, you queried this saying that I need a data from all the countries in Asia continent. So what happens is once you executed this query, for this query there will be a QID will generate, and this results will be captured in a cache. Okay, so what happens is, and you went to the another step and you are executing a different countries or a different metrics, but you want to run the same query, or you or some other colleague has tried to run to the same query. What happens is that query will not go back to the table to fetch the information. It directly comes to this QID and check if the similar query has been executed, and it picks the results from cache and provides to the person whoever is executing the same query. Okay, so I hope it makes sense. So what happens is the results will be quicker than before it going into the table. No need to go to table or scan whole thing and get the information back. It will get from directly from the cache for the similar query. That's what the point one says. Snowflake uses permanent during the session query results to avoid the regenerating the report when nothing has been changed. So what that means, the query should be exactly same, not even a single column, extra column you're pulling or extra clause you have put. The query should be exactly same to pull the information from the cache. Okay, and also this cache will be available only for a particular session. That is like you're trying to run in a one session, and once you close this session, this cache will get cleared. Okay, so next one is SQL and standard support. So let's read the statement. Snowflake offers both standard and extended SQL support, as well as the advanced SQL features like a merge, lateral view, statistical functions, and many others. So let's understand, it's as simple as the same other SQL databases. So you can use the same SQL queries what you are writing in a different DBs, which follows the ANSI model, right? So you can use the same thing when merge. When if you want to do a both insert and update in a single statement, you can use a merge. You can create a lateral views which pointing to the tables, or you want to create a user defined function, store procedures, or you can create a tasks. So all this can follow a simple SQL command, so which we have used from years in the past, and currently also some we are using in a on-premise. Okay, next one, if you see, next one is a fault resistant. So what is meant by fault resistant? This fault resistance will be available in a snow in all the on-premise as well. So all this fault resistance will be taken care by the DBS. If we get a chance to check with DBS will be taking a snapshot of the information, they will be capturing it, compressing it, and putting it in different racks for any disaster happen to bring it back into a normal stage. All this fault resistance will be taken care by the DBS. Usually developers will not involve over here, everything will be handled by a DBS. But as we discussed in the previous slides, Snowflake, nowhere the DBA teams are required. It's all will be taken care by the individuals, and most of the features will be handled by the Snowflake. Let's read the statement here. Snowflake provides exceptional fault-tolerant capabilities to recover the Snowflake object in the event of failure. That's a tables, views, database, schema, and so on. So what it means, example, let's take one example. There is a location table and there is a developer A. What happened is by mistake he has removed this table, dropped this table. Okay, but and in Snowflake, what happens is when you drop something, as I said, there is a QID generates, right? For every statement, there is a QID generates. So you can, using this QID, you can undrop the table. That means you can bring back the table. But in on-premise, what happens if something table drops or something, you have to raise a request, go to the DBA. DBA will ask for the time, what time it has been done, and they check what are the queries has executed and have to check if there is any snapshots are there, and then they will bring it back. So it's kind of like a one-day activity will be there. But in the Snowflake, what happens? It's very simple, as we heard. So it just run the undrop command on this particular query ID. So the table will reappears. Like this undrop, there are like, if you want to bring back a certain snapshot of the information, that is like, I need a snapshot of this particular table which is 24 hours back. So for that also there is a snapshot. You just give a time duration and provide the 24 hours, it automatically appears. Okay, like that you can bring all the tables, views, databases, schemas, and everything. And this fault tolerant, there is another topic called so failover, right? So what happens is, what happened in that failover instance, so this all information undrop and everything in control of only for 7 days. Okay, the first 7 days. In next 7 days it will go into a under archive, okay, deeper archive, and that can be handled only by a Snowflake team. Okay, that means there is a table dropped and 7 days you didn't recognize, and after 7 days it will go into a deep archive. So once it go into a deep archive, you won't be having a control. You have to raise a request to the Snowflake team. Snowflake team will retrieve the table for you, but it is a cost oriented task for them. Okay, so now we'll discuss about Oracle versus Snowflake. So Oracle is a transactional or analytical data warehouses. Majorly everyone will use a transactional. There is a, you can use it for the analytical data warehouses as well. And in Snowflake, it's an analytical data warehouse. What it means, transaction will be used for the day-to-day purpose. In sense, if you are withdrawing in money from a ATM for 10 times, all the 10 transactions you can capture in an Oracle. For that purpose it will be more useful. When it comes to the Snowflake, it is like majorly for the managerial tasks or for the KPS decision making. That's saying that you want to understand for a particular customer how many times he made a transaction. So like kind of like aggregations, you can do it in the Snowflake. Okay, on-premise or Oracle Cloud. So majorly we know that Oracle will be in an on-premise database which will be installed on your system, and we will be utilizing it. Now there is an OCI as well, that is Oracle Cloud Infrastructure, where some of the Oracles are been installing in that Oracle Cloud as well. But when it comes to your Snowflake, you can deploy it in any of the clouds, major clouds, that is AWS, Azure, or a Google. Okay, comes to the cost. So cost, fixed charge user per CPU support, upfront investment in hardware and software. Like we discussed in the first slide, whenever you want to have some DB on premise, what you will do, you will reach out to the company and you say that, yeah, I am buying this much of DB and space from you. So example, your company is a very small company, you don't think in the next 1 year you're going to reach a 20 TB. But upfront, what you do, you can't buy this one. It takes time to install or buy it, acquire it, and everything, right? So what you do is you simply spend 20 TB, paying some 1 billion pounds or $1 billion you pay, and you bring it, but you will be using only less amount of space or less amount of hardware. So the other rest is a waste of money for you until you reach to that point. But in a Snowflake, the cost is so flexible, you pay only for what you have consumed. That means you have a requirement of only 1 TB data, just you store for 1 TB, they will charge it for only 1 TB. And the cost will be calculated in Snowflake is storage plus compute. That means how much data you are storing plus how much process you are doing. That means how many queries you are running, what is the warehouses you are using to run it. So your cost will be based on storage plus compute. Let's see next features. So real app clusters, so rack, right? And a standby database needs additional standby data hardware, right? So high availability and disaster recovery. So that means we all know for any database or anything in a IT world, we need a disaster recovery, and high availability is where the company really gains a customers, right? So in Oracle, what happens, rack is the something they use as a standby database. That means if something, the primary node goes down, then there is a standby one, that is a rack they will use. And for that rack, they need to increase the standby hardware every time whenever the data grows. right? So whenever you want to increase the hardware, what will happen? So DBA team will talk to the clients and acquire all the hardware, and then they will roll out an email to the developers, testers, and everyone saying that they are taking a downtime for a few days. And once the downtime is done, they will put the hardware installed, and they will put an observation for a week or a month, and then they will finally conclude that everything is been done. But in a Snowflake, this is very easy. Okay, and the data will be replicated in a different centers, data centers. That means if one center got gone wrong, that means example take in India there is a three places: Mumbai, Delhi, and Vizag. It is there. So in Vizag there is a something called, so example, there is a tsunami or something happened and the data center gone down. Okay, and then what happens whenever a consumer try to run a query, once the one data center is gone, it will start routing it to the either Mumbai to Delhi to get the data retrieved for a customer. Okay, so this all will be done taken care by a Snowflake team. So if I read the statement correctly, data transparently replicated to the three data centers and automatic failover at zero additional cost. So what that means, automatically things will be taken care by the Snowflake team for the data centers replication, and failover also at zero additional cost, right? We no need to pay any extra amount for it. It will comes with the package once we choose for the company, right? Next one is scale up down options. Okay, for large data volumes, faster queries, more users or concurrent queries. Okay, so what it means, scale up is for large data volumes or faster queries, scale down is for more users came down and concurrent queries, right? So let's see, in Oracle it will be fixed. There is nothing called you can scale up or a scale down. If you want to scale up or a scale down, you have to inject a new hardware into the existing rack or a existing hardware, right? So, and if you want to put a new hardware or software, upgrade the software, what happens, it takes little days or a weeks. It needs a lot of planning. It has to take the down, and all the teams has to be involved upfront, right? So all this needs to be done. So mostly it's at a fixed, right? So in Snowflake, scale down and up is something very automatically can be done, and you can scale up very rapidly. So if you can see here, we can scale up from 1 to 180 128 servers within a milliseconds, right? So it is a automatic scale out also. Example, you have executed a query and there were 100 queries inside a particular task, and there is a 50 queries are already completed, then it will slowly scale out. You don't need the much computes to be executed. So it will slowly scale out, and it will try to put a low cost for you, and it saves and gives a good performance as well, right? So you can see database server clusters are automatically suspended when no longer needed. So it's a beauty, right? So to understand it more, so databases, when there is nothing to be done, you can simply shut it down. It will simply shut it down. Snowflake will take care of that one. It will shut it down and nothing will run and no cost for you. I hope this video helps you more. Stay tuned to this KSR Datavizon Snowflake program.